Hi, boys and girls. So I want to give a shout out today to Xavier, who had an awesome day in class on Monday. He knew exactly what we were doing. He was focused. He was working really hard, and I really appreciate it. And it goes to show that hard work really does pay off. So thank you. So tonight we're going to talk about what does proportional mean. Okay, here we go. Okay, so what is proportional? You've talked about this before. At least I hope you have. Pretty sure you have. Proportional is when two quantities have the same or an equivalent ratio. So, for example, if we have the ratio 1/2, that's the same as saying 2/4. So they are equivalent because 2/4 reduces to 1/2, and 1/2 is equal to 1/2, right? Okay, are these two ratios, remember ratios can be written as a fraction, are they equivalent? 3/4 and 30/40. Well, we want to know, are they proportional is saying, are they equivalent? It means the same thing. There's a couple of different ways to check this. One way is to reduce both fractions to see if we get the same. So 3/4 is already reduced, so 3/4 is 3/4. 30/40, divide both by 10, and we get 3/4. Yes, they are equivalent, so yes, they are proportional. You could also do that little cross multiplication thing. So 40 times 3 is 120, and then 4 times 30 is 120. So since both of those are the same, then yes, they're proportional. The two ratios are equal. All right, so H-E-B is having a sale on apples. You can buy 4 apples for $1.60, or you can buy 10 apples for $4. Is the sale price of apples proportional? I did not spell proportional correctly. Okay, I'll fix there. So we can set up a ratio. Okay, so we can think about, we've got our apples for $4, or 4 apples, so the number of apples, we have 4 apples, and then the cost is $1.60. Okay, so let's say we do $1.60 divided by 4 to get the price per apple. So $1.60 divided by 4 is 0.4, meaning each apple costs 40 cents. Let's say we buy 10 apples, and that costs us $4. So we do $4 divided by 10, and we get 0.4, or 40 cents. So are they proportional? Yes, they are. Why are they proportional? Because that ratio is the same. When we did the cost divided by the number of apples, we got the same ratio of 0.4. So yes, they are proportional. All right, now we're at Walmart, and they're selling boxes of Oreos in 2 sizes. The 20-ounce package is $2, and the 32-ounce package is $3. Are the cost of these 2 packages proportional? So we have the size of the Oreo box, and then we have the cost of the Oreo box. So for 20 ounces, it's $2. And then for 32 ounces, it's $3. So if we do 2 divided by 20, we get 10 cents per ounce. And then if we do 3 divided by 32, we get about 9 cents per ounce, a little bit more than 9 cents. Now that usually happens, right? If you buy a bigger package, you usually save a little bit more money. So are these two proportional? No, they're not proportional. They're not proportional because the ratio of cost to the Oreos was not the same. So for 2 things to be proportional, we have to have an equal ratio. When we take one item and divide it by the other, one quantity divided by the other quantity, we need to always get the same ratio. Why are we doing this? Well, there's a special kind of linear relationship that's always proportional, and that's what we're going to talk about tomorrow. Let's say we have this right here. Okay, so if we take all of our y's and do y divided by x, we get 6 divided by 1, which is 6. We get 12 divided by 2, which is 6. We get 18 divided by 3, which is 6. We get 24 divided by 4, which is 6. So this table shows a proportional relationship because the ratio of y divided by x is always 6. Hey, just real quick, what's the slope of this? So we're adding 6, adding 1. Adding 6, adding 1. Adding 6, adding 1. So the slope is 6 over 1, which is equal to 6. What do we notice? Here's what I'd like you to do for your question. I would like you to hypothesize, so take a guess. What do we notice in proportional relationships about the ratio of y divided by x and the slope? What conclusion can you draw about the ratio of y divided by x and the slope for proportional relationships? So for proportional relationships, what can we conclude about the ratio of y divided by x and the slope? All right, have a good night.